understanding the fuzzy sets in a much better way. So the overall aim of the presentation is to define total ordering. So what is the meaning of that? Before entering into, I just wanted to explain it in a simple layman point of view. Suppose if we are given with two real numbers, for example, 3 and 4, we will be able to say that 3 is less than 4. What is the meaning of it? By means of less than relation, we can compare any two real numbers. Mathematically, we say this as like less than relation defines total ordering on the set of real numbers. But we do not have such kind of total order relation on the set of fuzzy numbers. This was an open problem for more than 3 decades. And in the year 2014 or 15, this total ordering problem has been solved. Later on, the same idea which I have used for defining total ordering on the class of intergenistic fuzzy sets, which is further generalization of the fuzzy sets. And now let me get into the talk. So what would be the overall aim of the talk? If you are given with two fuzzy numbers, let us say fuzzy number A and fuzzy number B, how we are going to compare them? We are going to define some relation by using which we are going to compare two fuzzy numbers. So this is what the ultimate aim of the presentation. Of course, there are a lot of ranking principles which are available in the literature. And if you are trying to give a lecture on this particular topic, we can give hundreds of lectures. And in today's lecture, my focus would be mostly on introducing one of the methods which are available and which defines a total ordering. In addition to that, I wanted especially the PG students as well as the research scholars who are working in this area to take participate in the interaction. So I strongly believe that the learning would be more good if you guys are interacting. So please feel free to interact at any point of time. If you find the talk to be difficult or some concept to be repeated, I'm ready to explain, right? I strongly believe that people are present here. Some of you might hear some talks related to fuzzy, but the rest of the people might not be. So I wanted to make the talk to be as simple as possible, right? So now let me share my screen.
Now it is visible.
Yes, it's. So good morning, one and all present here. So as I concluded or as I have summarized, I'm going to give a talk on fuzzy sets and its applications. So what are fuzzy sets basically? So the fuzzy sets are introduced by Zade in the year 1965 as a generalization to classical sets. As we know that a classical set, which I mean hereafter I refer it as crisp set. So how can we define a set? A set is nothing but a collection of well-defined objects, right? So what is more important here? The term well-defined. So what is the meaning of well-defined in the definition of crisp set? So the definition of set should not be a person dependent. That is what the meaning of well-defined. But another way of defining set is by means of its characteristic function. So where characteristic function is chi a is a function from any universal set capital X to the set containing 0 and 1 element. So what is the meaning of it? Each and every element of universal set, we are going to assign either 0 or 1. So if it's satisfying the condition of being in the set A, we will assign the membership, we will assign the value 1 to it. For example, let us consider the set of natural numbers which are less than 6. So what is the underlying set or universal set with respect to this example? The set of natural numbers. So what are we going to do? We are going to consider the set of natural numbers as a big bag, right? So from that bag, we are going to collect certain elements which are satisfying some condition, and we are going to consider a small bag, and we are going to name it as a set, right? Suppose if I insert my hand into a big bag of natural numbers, if I am picking a number, for example, the number is 7. Whether it's satisfying the condition of being in my small bag, in order to be in the small bag, the number should be less than 6. 7 is not less than 6, so I'll throw it outside. What is happening here? I'm assigning 0 to it and I'm throwing it outside. So in a similar way, if I'm taking a number 3, which satisfies the condition of being in the set, so I'll assign 1 to it and I'll include it in my small bag. So checking my set. So set, I'm naming my small bag as a set. So set consists of 1, 2, 3, 4, 5. So what is happening in the case of classical sets? By use of characteristic function, we are defining our set, right? So what does it do to the universal set? What does this chi a does to the universal set? So what actually is happening? It divides the entire universal set into 2 parts. It divides the entire universal set into two parts. One part consists of elements which are satisfying the condition fully. Another part consists of elements which are not satisfying the condition fully. For example, in this case, with respect to this, let us consider this. I'm using mouse, so the handwriting would not be so good. So please bear with me, right? So let us consider the circle as a set of natural numbers. So what is the meaning of this? Here we will have all the elements which are satisfying the condition of being in the set A, which is nothing but what? 1 to 6, right? Then what about the elements which are here from 7 onwards? The element would be here, actually including 6, right? Because there we were considering what? The set of natural numbers which are less than 6, so 1 to 5. So what does this characteristic function do to the universal set? It divides the entire universal set into two parts. One part is 100% known to me, another part is 0% known to me, right? So suppose if somebody is making you understand how to divide something, some set of objects into two parts, what would be the natural thinking? So what do we think? Why don't we need to divide only into two parts? Can we divide it into 3 parts? Can we divide it into 4 parts, right? So this is nothing but the further generalizations, right? Once we are able to divide 4 parts, 5 parts, 6 parts, in general, we can write it as some n parts. If we are able to divide something into some n parts, basically, right? So what would be the utmost generalization? It is nothing but what? Infinite way of partitioning the universal set. So let me repeat. So the characteristic function divides the entire universal set into two parts. What is the further generalizations to it? It can divide the universal set into 3 parts, 4 parts, in general n part. What would be the utmost generalization? We can divide the entire set into infinite number of parts, right? Now the question is nothing but what? So what do I try to say basically? Now we are like the conventional mathematics rely on the classical sets, and the classical sets rely on the two-valued logic or binary logic. Now we wanted to increase this logic. We wanted to study about multivalued functions. Now the idea of multivalued functions, we need to understand. In order to understand the multivalued functions, we need to know what is happening in the case of set theory. That is the reason why I have discussed this. Now the question is nothing but what? Instead of two logic, why should I need to increase the logic? Instead of two-valued functions, why do I need to consider the multivalued functions? So in what way it improves the scenario, or in what way it can improve the modeling, the mathematical modeling? That is the question. So we need to answer to this question first of all. See, as we have discussed about the classical sets, one way of understanding this classical set is nothing but what? If there is a question, the question can have only one correct answer. For example, the question here, the set of natural numbers which are less than 6, right? So what would be the answer to this question? It is nothing but the set consists of 1 to 5. This answer would not be dependent, like person dependent. If I'll ask a question from people who are presenting in this talk, their answer would be, all of their answers would be 1, 2, 3, 4, 5, right? So it is not person dependent. So how can we understand the crisp set in a layman point of view? It is nothing but what? A question can have only one correct answer. In another way, I can say that when we are trying to model the real life problems, what kind of models can be modeled better using crisp set or classical sets? The problems that are so precise in nature, right? Now, what we are really interested in, instead of two-valued logic, we wanted to increase the number of logics. But what is the reason? Why do we need to increase the number of logics? Let us try to understand this by means of a classical example of a machine. As all of you know that machine, almost all the machines, including computers, are the devices which we are using currently that uses binary logic, right? So what is the meaning of it? Like, let me consider one of such machines. For example, the fan. When the fan got introduced to the market, how did it work? Either you can switch on the fan or switch off the fan, which means what? Either the fan can run in 100% speed or 0% speed, right? Now, but depending upon especially the weather of Tamil Nadu, one can understand and agree with me that at some point of time, in the year, we feel like we cannot run the fan in 100% speed. If we run the fan in 100% speed, we might feel some cold. If you are switching off the fan, by that time also we will feel some humidity, right? So what do we expect? We expect our fan to run between 0 and 100% speed, right? So this is our real life problem. So this is how the fan got evolved. So how did the fan got evolved? From on or off. After that, we were having the fans that was having a regulator that was having 5 switches, right? 1, 2, 3, 4, 5. What is the meaning of it? You can stop the fan, or you can make the fan to run with 20% speed, 40% speed, 60% speed, 80% speed, and 100% speed, right? So while increasing the logic, while increasing the number of values, instead of 2-valued logic, previously the fans which were having on or off switch, right? 0 or 1, right? So instead of 0 or 1, we were considering the regulators, which consist of 5 switches, which imitates the logic like this: 0%, 0% speed, 20% speed, 40% speed, 60% speed, 80% speed, and 100% speed. So whenever we are increasing the number of values of the function, it improves the modeling basically, right? So obviously, we will be interested in purchasing the fans which are having regulator than the fans which are having only on or off switch. So this is how in a real life we can connect the idea of multi-valued functions. Now, what kind of fans we have now? It is not only regulator. It's not only consist of 5 switches. It is consist of what? Infinite number of switches. What is the meaning of it? You can stop your regulator between. You can make your regulator to stand between 0 and 1 anywhere. So what is happening currently? Previously, the classical sets were started with 2 logic. Previously, the classical sets were started with 2 logic. Then further, you just try to understand the scenario by means of the fan example. Then we have increased it to 3 logic, 4 logic. Then we will have some n logic, right? So from n logic, we can go up to infinite logic. So whatever the fans which are currently working, that are working in infinite logic, what is the meaning of 0 represents the fan is in off condition. 1 represents the fan is in 100% speed, right? So in between, how many values are there? Infinite number of values are there. So how are we going to define fuzzy sets now? In the case of classical sets, what do we have basically? We have a 2 logic. By means of 2 logic, by using truth function or characteristic function, we are defining the idea of sets. So in the same way, in the case of fuzzy sets, what do we have with us? We have an infinite logic. By means of one function, we are going to define fuzzy set. So the function we are going to name. Here we have given the name of this function is nothing but what? The characteristic function. So and we are going to give a name for this function. We are going to call it as membership function. So the classical sets are characterized by means of characteristic function, and the fuzzy sets are characterized by means of membership function. Obviously, the membership function is nothing but the generalization to classical characteristic